So this is the maturity of analytics and business intelligence, uh, and we are, uh, and I explained how this approach goes. So this is kind of the simplest, and we go out to the more advanced. Now, here's the same idea. Here's the same picture, basically. We have reporting, analysis, monitoring, and prediction. And so, by the way, we use the word predictive analytics. We also use the word data mining. A lot of different words, more or less the same meaning. We're not going to go into distinctions about the meanings. Now, difficulty to implement as you move out. Of course, it's more difficult to implement, but you also get increasing business value. And the idea is to search the data for non-obvious knowledge that wasn't previously known. So that's the idea, and we'll see what we mean by that. So all data is not valued equally, but how do you know which data is important and which isn't? So we'll talk about hot data, which is data that's basically useful, versus cold data that doesn't appear to be useful. It may actually be useful, and that's part of the value of doing data mining and predictive analytics, is that you find out that some of the cold data is actually useful. So lots of data is either useful, either not useful, or we don't know how to use it. We call it noise sometimes, or at least it appears to be noise. In the old way of thinking, we made a decision to throw it out. So before the data mining technology, in a statistical approach, we would basically throw out we try and get rid of the noise. But we don't want to do that anymore. That's part of the value of Hadoop, because Hadoop, I didn't say it, but basically it allows you to store lots of data. So the advantages of it for companies is now becoming understood, in the sense that they can keep much more data around for a lot longer time. And before they wouldn't even want to do that, but now they want to do that because we can hold on to more data because we may realize it's valuable later. So we don't know that it's valuable now, but it may turn out to be valuable later for something new, or for some new events that we're trying to understand. The old data may help us. Part of the value of discovery is that through discovery we can identify what data is hot and what data is cold. So discovery not only allows us to use the data to find new things, but it also allows us to figure out which data is important. And that's a new idea that wasn't really seen before in statistics, generally speaking. One more point, and that is that remember we talked about the DNA example, where you send your money and you can find out your ancestry. So a lot of that data would be considered noise. In other words, we don't understand what most of the DNA sequences are in our DNA, so it would be considered noise, but maybe later we might discover that it's not noise, that it's not garbage. And Hadoop, as I said, allows you to store a lot more data than traditional technologies. So you could hold on to this data and then maybe figure it out later. Okay, so here we're talking about the difference between traditional business intelligence. Now, I use the symbol BI for business intelligence. Traditional BI is quite different from predictive analytics or data science. So how is it different? In business intelligence, we choose a business outcome to improve. So we want to, there's something that we're trying to accomplish. We're trying to improve some business outcome. For example, suppose you're a mobile telecom provider. So like your SoftBank here in Japan, or your Docomo here in Japan, or your whatever. What's the other one? AU here in Japan, or whatever, or in some other country. And you have a good customer base. That means you have a strong, a good business. You have a lot of customers. And of course you want to avoid customers leaving. And that's in this business, or in many businesses, it's called churn. Churn means when the customers leave. So what do you do? So you might gather all of your experts. And I'm talking about in a business intelligence scenario. So you'll have your salespeople in the retail stores. You might get them. So you get all the retail stores, all the people working there. You get them together and you try and get some, ask them to make some comments, ask them to for their suggestions. And you get the marketing people, the marketing experts. Those are different than salespeople. And we get in a room and we discuss it. What sort of information? I guess I'm going to turn this thing off right now because it's annoying me. By the way, I recommend this to you guys. If you use Dropbox, you might want to use this instead. It's called BitTorrent Sync. It doesn't work in the cloud, so to speak, so you don't have your, but it's free, and you can, and the file size is unlimited, and you can transfer files from one of your computers to another, but there's nothing in the cloud. It's not stored in the cloud at all. It's only stored on your local computers. Anyway, I'm going to pause it. Okay, so anyway, what do you do? So you gather all the experts, the salespeople, the marketing people, you get in a room, and what sort of information could be gotten about our customers to help prevent churn? So we ask the experts. So we say, okay, what data do we need? What data should we collect? Should we collect their birthdays? Should we collect where they live? Should we collect their income? Should we collect data about their favorite television show? Should we collect data about how old? We already said the age. Or should we collect about their favorite color? Should we collect whether they are using Android or iPhone? Right? Lots of different questions we don't know which data is important, which of these variables are important. So I'm like working at the top of the company. I'm in top management, so I'm going to ask the salespeople. I'm going to ask the marketing people, and we're going to get together. We're going to come up with a set of variables, a set of data that we should collect in order to help us prevent churn. Then we decide what data is important. Then we have our business intelligence people. Then we go to our business intelligence department, and we ask them to create a data model. Model means they're going to try and predict who is going to churn. And they create reports, and then the marketing people will supposedly be able to use these reports to reduce attrition. So the marketing people will then know, okay, well, because of the model that the model that the business intelligence department has set up, the marketing people will know, oh, this guy is likely to leave, so let's offer him some special deal or whatever. And also, they also try and determine who's a valuable customer and who's not. So if it's not a valuable customer, if they're not spending a lot of money, they may not give them the offer of a special deal or something. But if they are a valuable customer, they may offer them some special deal. So this is the traditional approach, though. So how does predictive analytics handle this problem? So reduce churn through predictive analytics. Still, we do choose the business outcome, which is, in this case, we're trying to prevent churning. But we don't decide what data is important. Instead, we include all the data. So this is different, very different than the traditional approach. Every shred of data about customer, about mobile networks, about geolocation data, everything. We assemble it all. Then we run predictive analytics algorithms on all of that data. Those algorithms, if they work, will find out which data is important. So you can see it's a very different process. One is we ask the experts, and the other is we let the computer decide. So the experts haven't decided, the computer algorithms have decided. So the data mining department might provide us a list the data mining department might provide a list to the marketing department and say, here is a list of 30,000 customers that have a 65% chance of leaving. I forgot the word chance there. So, you know, these guys have a pretty strong chance of leaving, so you better do something. So predictive analytics is very different from traditional business intelligence. And you can see the difference here. Decide what data will be relevant versus, that's here, run algorithms on the data to find a model. And both approaches are necessary for the contemporary enterprise. So you want to do both. One requires experts who have expert knowledge. We call it expert knowledge or expertise. But this could also be called bias. So, you know, bias is considered a bad thing, right? Like you might say somebody has a bias towards eating fatty foods or something like that. Anyway, it means generally it's considered a tendency towards something that may actually interfere with the analysis. In this case, we're talking about bias in that sense. May actually interfere with the analysis because they have expert knowledge that's going to lead them to say, oh, this is important and this is important, but maybe that expert knowledge is flawed in some way, but they don't know it. You know, it's kind of like the idea of when we do an experiment for a new drug, we give the patients, we give half of the patients the medicine, and the other half of the patients we give like just a sugar pill. Because we know that if people know that they're getting the medicine, just that will cause them to feel better. It's actually quite true. It's very amazing. So if you think you're getting medicine, you'll feel better, even if it wasn't real medicine, even if it was just a sugar pill or just nothing. So that's kind of like bias. And also, we do the same thing with the doctors who are evaluating the patients, because if the doctors know who got the medicine and who didn't, and when the evaluators don't know, it's called double blind. The patients don't know, and the doctors don't know. So if the evaluators know who got the medicine and who didn't, then they're also going to be kind of biased in their approach. They're going to think that this person got the medicine, so maybe they should be better, and somehow they'll actually figure out or find that they're better. So that's kind of bias also. So anyway, that's the idea of bias. So going back here, two very different approaches. One requires experts who have expert knowledge or expertise, but this could also be called bias. The other, so that's business intelligence, right? The other uses math, science, and predictive analytics. Both are important, but predictive analytics does have many business use cases. Business use cases means uses in business. So we have data scientists unleash algorithms to find predictive models. So we're kind of comparing the methodologies used by data scientists versus statistician versus a business information analyst. So I guess the idea here is that, you know, this is a more primitive tool. This is a bit more powerful, but the data scientist has now all these machine learning algorithms are like little robots that he can unleash on the data to find out all kinds of information that wasn't previously available. Okay, this is just a list of different kinds of algorithms, and hopefully we'll get a chance to talk about these or some of these in the class. We're going to start out using Excel, and in Excel we'll only use actually we won't be using these, but hopefully we'll also get to talk about Weka, which is a free software that where you can actually use all of these, I think, almost all of these. Okay, let's stop the video here and come back to the next slide, which is this one.